Today we're going to talk about our limits at infinity. So 0.7 is what happens on the far right side of the graph and the far left side of the graph. Okay, notation, as x approaches infinity means x continues to increase without bound. Okay, so again, the far right side as x gets bigger and bigger. And x approaches negative infinity indicates x decreases without bound. Notice the difference here, the negative sign is in front versus after. If it was after, it would indicate coming from the left side. So we will write the limit of as x approaches infinity of f of x equals L if f gets closer and closer to L as x approaches infinity, and the same thing as x approaches negative infinity. L is going to be a horizontal asymptote, and infinite limits describe asymptotic behavior. Okay, so describe the behavior in the figure. It is simple as this. When we look at the left side of the graph, the limit as x approaches negative infinity, and we're going to use g of x because that's how it's labeled, of g of x, notice it kind of levels out right here at 3. Okay, and on the right side of the graph, the limit as x approaches positive infinity of g of x, it kind of levels out here at 7. It's that simple. Okay, do the same thing with the next two. The limit as x approaches negative infinity of 2 to the x equals, notice it's kind of leveling out here at 0. And the other side, the limit as x approaches infinity of 2 to the x power is going to equal positive infinity because it's going to continue growing without bound. Okay, the next one, the limit as x approaches negative infinity. Now, notice this graph is going to keep oscillating back and forth. Okay, because it oscillates back and forth, this limit does not exist. Okay, it's just going to keep going back and forth between -1 and 1, so we can't do anything about that or say anything about that. The limit as x approaches positive infinity of sine of x also does not exist for the same reason. Okay, just a little bit of information here. It is a theorem. As n is greater than 0, the limit as x approaches x to the n, x approaches infinity of x to the n power is going to be infinity. So if it has an exponent, it's going to get bigger and bigger and not stop growing. And the limit as x approaches infinity of x to the negative n, makes it a fraction, is 0. Pretty much a summary here of that statement. Okay, for these, if I were to plug this in and look at the limit as x approaches infinity, for the numerator here, 20 times x squared minus 3x is going to be, just for the numerator, infinity. And same thing for the denominator. The limit as x approaches infinity of the denominator is also going to be infinity. So we cannot use the quotient law directly, because this is indeterminate form. So we're going to do a little algebraic manipulation. And the greatest degree in the denominator is the 5th power. So what we're going to do is actually multiply everything by x to the negative 5th power, which is the same as dividing by x to the 5th power. So what that does is gives us 20x to the negative 3 minus 3x to the negative 4 over 3 minus 4x to the negative 3 plus 5x to the negative 5. The reason we want to do that is because I can find the limit as x approaches infinity using this much easier than I can up there because this is indeterminate form. If I have really 20 over x to the 3rd and 3 over x to the 4th, when I plug infinity into the numerator, the limit as x approaches infinity for the numerator is 0. The limit as x approaches infinity of the denominator is 0, 0, and 3. So we can find that the limit here is 0. Okay, so we're going to use that idea, and I'm going to erase this work that I had here because I'm going to do it differently. Here. Okay, so here's your theorem. This is going through essentially the same process, and it has you pulling out coefficients here. So what we're going to do for this next problem, example 3, is because this is infinity, this is infinity, we are going to divide both the numerator and denominator by the greatest degree in the denominator. So we are going to multiply by x to the negative 2 and x to the negative 2. So the limit as x approaches infinity, 7 halves minus 4 halves is 3 and 3 halves plus 7x to the negative 5 halves over 1 minus x to the 3 halves. Sorry, to the negative 3 halves. If I split this up now, the limit as this approaches infinity, the numerator, we get infinity. As this approaches infinity, this is 0, so that's 1. So infinity over 1 gives us a limit of infinity. For the next one, it's important to note that x to the third plus 1 inside the square root is the same as saying a 1/2. So this is behaving like x to the 3 halves. So I'm going to multiply by x to the negative 3 halves throughout. So when I do that, I get the limit as x approaches infinity of x to the 1/2 divided by x to the, this is really saying x to the 3 halves times the square root of 1 plus x to the negative 3. I'm going to simplify that. So when I multiply it, I get, sorry, doing notes off to the side. Okay, so when I simplify that, I end up with, I factor this out, multiplied by this, I get the square root of 1 plus x to the negative 3 here. So this goes to infinity. This is 0, so the square root there is 1. We get infinity there as well. I just lost my pen, so bear with me for a second here. I'm going to reopen this. The last problem in your packet, we have 16x squared inside a square root, so that's going to behave an awful lot like just an x. So when I simplify this here, like we were with the rest, we are going to divide by x or multiply by x to the negative 1. So if I multiply this by x to the negative 1, I want you to pay attention to the fact that it's going to be different when x is positive versus when x is negative. So if we do the limit as x approaches positive infinity, we're going to have 12 plus 25 over x divided by the square root. And then once this is inside the square root, it's really like an x squared. So 16 plus 100 over x plus 500 over x squared. Okay, so we're going to simplify this here. This is 0 plus 12, which is 12. This is 0, this is 0, this is 16. So the square root of 16 is 4. So when I simplify 12 divided by 4, I get 3. When x is negative, though, we're going to have something different. And that's going to be this negative here, so negative infinity. So 16 plus 100 over x plus 500 over x. The only thing that's going to change is because the x is negative here, we are going to have a negative 4, which simplifies to negative 3. And that is it. Let me know if you have any questions.